Welcome. In this video I'm going to show you how you can obtain the common language effect size measure for a one sample scenario using Python. I'm using Jupyter Lab with Python version 3.12. This video will focus on how to obtain the measure, not so much if you should. To show you how this can be done, I'll need some example data. I already loaded this, so I first loaded pandas, so I could load student statistics file, which contains some results from a survey among students. Didn't need all of its data, I just need one ordinal field, so I'm using teach motivate for that. As you can see, these are not in the proper order, so what I also assigned is a variable coding, which has a dictionary with the categories and the corresponding number that that category should get as a value. In a separate video, I show you how you can actually simply use my own library, stickpad-p, which has a function for this. But if you don't want to use my library, there are others who also can work with this. They do usually need then the data. We first convert it to a list. We then actually remove missing values and then replace any of the values by its numeric value. So that's what most other libraries actually need, numeric data, so they can't actually use the predefined coding. Now after that it's fairly straightforward. For example, the CLES library of course has this available for one sample. Once you've installed the library, you can load it as any library. Oh, I didn't install it yet, so I need to run that pip install first. And after that, I should be able to run this. Might take a little while before it's actually run. And then I should be able to use this function as well. And there we have the result. Now note that this is a percentage, so it's not a proportion. So if you want, you can divide it by 100 to get actually a proportion. It will always be between 50 and 100. So if it's actually less than 50, then this is returning 100 minus the result. So bear that in mind. If you want to use the Pingoian package, they actually also have a function compute effect size. So again, install it first and then load the library or import only its function. We have to create a second variable with simply a list of the same length as the data with our hypothesized value. So we simply take that hypothesized value of 3 that I have times the number of scores that I had, and then I can actually trick it into calculating the effect size measure, in this case 0.3518. If you don't want to use any libraries, you can also do it the hard way. So I'll first for sure make sure I'm using just a Python's core collection type. So everything is now a list. I remove the missing values again and I replace everything so I just have numbers. I'll simply use the mid-range as my hypothesized median, and the sample size is easily obtained by using the len function. The first method is just counting how many scores are there above the hypothesized value and divide that by the sample size. So we can simply do a for loop comprehension here. It just goes over and only selects scores that are above mu. Then I know how many are greater, and then simply divide that by n. Some will actually argue to add half of the scores that are equal. So in this case, I'll simply use that same idea again, but now use equal to or equivalent to. So I get the number of scores that is equivalent. And then I simply add half of those to my previous result, and I get a slightly different result. If you like, the CLS library returned this one, but it actually returned the complement. So if I do 1 minus this, I get that same result as we saw earlier with the CLES package. A third formula is using the rank by serial correlation coefficient. Now I have a whole separate video on how to obtain that one. So here I'm just quickly running some code to obtain it. But have a look at that video or notebook in case you're interested. Once you have that, the formula is very quite simple. 1 plus that rank by serial one and then divide by 2. So that's fairly straightforward. That's 0.2619, and that's also what the effect size library actually in R will give you. The last formula is one that's using a cumulative density function of the standard normal distribution. This one uses Cohen's d for 1 samples. Again, I have a separate video and a notebook about that, so I'll simply do here only the code to get that value, and then I need that cumulative density function. So I'll load from the statistics library that comes with Python the normal dist function, and then I can actually just fill out the result. Normal dist isn't defined because I didn't actually activate this one, and now it should work. It's also what the R's effect size library will actually return. Okay, I hope this video was helpful, and thank you for watching.